Let's take a look at lack of root fusion. Again, during the root pass on this weld, these are two plates that are 0.625 inches thick, and during the root pass, the very first pass that the welder made on this weld, there's a lack of fusion. Here's a typical root type of geometry where there's good melting of the base metals and the filler metal, and we have a good strong bond. But in this area right here, there was a little lack of sidewall fusion. We did not melt into our machine sidewall. So let's take a look and see what the lack of root fusion looks like. The lack of root fusion is on the downstream side of, here's the center line of this weld. It's on the downstream side. Upstream side, we have good fusion. And again, I'm using a 70 degree. 70 degree is good for interrogating the root of a weld. So I calibrated on my IIW block, set my reference using the 0.6 deep side drilled hole, and to bring that signal to 80% full screen height, it requires 75.1 dB. So this is running quite hot. So looking at, this is a clean section weld. Over here is clean. Nothing much going on. Scanning. Boom. Look at that exploding signal right there. Very high amplitude signal. Plots right to the thickness of our plate. Right at the ID. Very sharp signal. Very strong reflector. Drops off very rapidly. It's the machine surface we're looking at. I'm going to pull 12 dB out of here. This is such a hot signal. Let me remove 12 dB right there. We took 12 dB out from our reference, and look, that's a good strong signal still. Very good amplitude. Even with 12 dB out, I'm at about 100% full screen height. Distinctive, very distinctive start stop. Gone. Bringing the probe back to us. We're running parallel to that indication. And gone. Very distinctive start stop. See this little guy popping up here? That's our actual root. That's good root. We're looking at a lack of root fusion. Good amplitude. Let's look at on the other side of the weld. I can catch the tip of it on the other side of the weld with a 70 degree. Look at the amplitude is quite a bit lower. I am scanning right now from the upstream side and looking at that root. And I can see that lack of fusion. It drops off very rapidly. Distinctive start and stop. But you can see it's quite lower amplitude, and I'm really more catching the top or the tip of it. But it still drops off very rapidly, but a little bit hard to see. It's on the downstream side, and let me see where it plots. If I get the plot right at the right there, it's plotting at the ID or at the bottom of our weld, and look at the relationship to where this probe is to the center line of this weld. I'm quite close, meaning I have to reach out further across the center line to touch it. Now let's compare. Here's the probe on the upstream side. Let's look at the downstream side and see and there we have it. Here on the downstream side, plotting to the thickness of the plate, and I'm a little bit closer than I was on this side because it's on the downstream side of the center line. But you can see, look at the amplitude I'm getting a very powerful signal from the center line the side of the weld where that defect is, and rapidly drops off. So that is your typical lack of root fusion. Very high amplitude. Again, I took 12 dB out of my reference and it's still blasting off the screen.